So I wanted to go in on lecture one day, besides having you look at the syllabus and all that, I wanted to give you a little bit of the probability, take a look at how homework one is going to work, and maybe get some of you off to working on homework one because you're like looking through it and seeing it works fine. But I'm also going to support this with a homework one video that looks at some of the problems actually in homework one. And on top of that, the homework is not due right away. It's going to be due after class 2, so you can take it as far as you can, and if you get stuck, you're not falling way behind. But if you get all the way through it, that's great. Then you can get in touch with me during that time as we're heading into homework 2 and say, I had trouble on homework 1, can you help me with the specifics of that? But I want to put out the groundwork for probability on this. So I want to start off my expression about probability that most people talk about probability and statistics together. They're usually linked together. And because that's so important, I'm going to start off by telling you what statistics are. And then probability will have more of a purpose and use. Statistics look at numbers after they happen. So after something happens. We are able to see what happened in the past. How did something play out? What was the result of that? Probability looks ahead. Probability looks at expectation, which is how things should work. It's not a promise that they will be, but what is the likelihood? What is it the expectation is? What is probable? And so we're going to be looking at the likelihood of something happening, and nothing is more than 100% likely to occur. So we keep that in mind. We want to know that probability equals a fraction. And I like to look at the fraction of what it is by establishing the denominator first. I know most things go from top to bottom, but let's build a strong foundation for this. And this would be, down here would be the number of possible outcomes. All right, so you see that number sign? All right, some people call it a hashtag now. And years ago, people thought it was a tic-tac-toe sign, but it means get me a number of possible outcomes. And that's the bottom of the fraction. That'll be the higher of the two numbers unless they're tied. And the other number on the top is the number of successes. So you make a fraction where the number of things that do what you're looking for goes on top, and the number of possible ways that could turn out at all goes on the bottom, which is, if it's impossible to have success, like never going to happen, truly never, that would be a 0, and no matter what the denominator is, the probability will turn out to be 0. If something is guaranteed to happen no matter what, then the number of successes will be exactly the same as the number of possibilities, and no matter how big the numbers get for the different numbers of possibilities they match, it's going to make a fraction that equals 1, which is the extreme values we can have for probabilities. So we're going to see that any probability I'm going to set up a compound inequality. Sounds scary? I hope not. 0 is less than or equal to any probability. So the probability might equal 0, but 0 is as low as it can go. And the probability is smaller than or equal to 1. All probabilities lie between 0 and 1. You might think of that as 100%, but 100% is 100. Percent means over 100. 100 over 100 gets you 1. So you can think of it maybe as a decimal. One of my friends says, think of it as a decimal to 3 digits, because you can always get a good look at what's going on when you look at a 3-digit decimal, right? If I say, well, 7/8 or 6/7, you might not know, but if you put the 3-digit decimal, you're looking at 3 digits of accuracy of what's going on, so that's good too. But it's no smaller than 0, so it won't be negative, and it won't be bigger than 1. They're going to be positive fractions, maybe equal to 0, maybe equal to 1. So I don't want you to necessarily memorize this, but I might say, what's the probability of rolling a die? A die is a single one of 2 dice that has 1, 2, 3, 4, 5, and 6 on it. It's the probability of rolling one die and getting a total facing upward greater than 8. How many of them are greater than 8? None of them, because we have this. This is called my sample space. We can get a 1, we can get a 2, we can get a 3, we can get a 4, we can get a 5, we can get a 6. How many total? 6. You put a 6 in the bottom of the fraction. How many of those are bigger than 8? None of them. So that probability would be 0 over 6 and come out to 0. It's impossible to roll 8 or higher on a single die. It's my sample space again. And I'll say, suppose you roll the dice. What is the one die? What's the probability that number comes out smaller than 10? You'd say there are 6 on the bottom because there's 1, 2, 3, 4, 5, 6 total. They're each smaller than 10, so all 6 are there. 6 over 6 makes 1. The probability that the number will come up smaller than 10 is a probability of 1. Now we can get into things that are a little more focused. What's the probability that the number is even? 6 numbers on the bottom, so 6 numbers for the fraction. That's even, and that's even. So we got 3 out of 6, half of them are even. And those are all probabilities because you've set up a 6 on the bottom of each fraction and a number up there. I've set up Connect Math and my own results that I don't need you to reduce the fraction to get full credit. Okay, if you said 3 out of 6 of those are even, that would be correct. 1 out of 2, also correct. It's not that 1/2 is better than 3 out of 6, because as far as me knowing that you know the probability, my looking at 3 over 6 tells me you know there were 6, you know 3 were good, you know to set the fraction up that way, and I can see your 3, your 6, and that it makes 1/2 myself. I can see 3 things are correct in an unreduced fraction, whereas getting it 1/2 may not fully have you comprehending. Half would be full credit, no worries about that, but 3 over 6 would also get you full credit, which is different than has happened in almost every math class you've probably been in before. If the probability of an event happening equals, we'll call it the letter P. Now that's a number between 0 and 1. The probability is that, then the probability it doesn't happen is called P prime, the complement. Complements go together. Complementary angles make 90, supplementary make 180, but complementary, if you want to complete the package, if you got it all, then you would have 100% of what's going on. So if I said there's a 20% chance of rain tomorrow, what are the chances it won't rain? The most common answer I get is 80%, and that's correct. But if it's a 20% chance of rain, that's a 0.2 for the probability that it will rain. 1 minus 0.2 get me the 0.8 for the 80%. So you take the one that represents 100%, you subtract the probability that something happens, and that gives the probability of what we call everything else. At least that's what I call it. The complement of something is everything else. So you take one that's all possible occurrences, subtract the probability of something happening, and the remaining stuff that it doesn't happen gives you what's called the complement. As I mentioned, the sample space over there, when I put 1, 2, 3, 4, 5, and 6 for the ways the dice might turn out if you throw a single die, the sample space represents all of the possible outcomes. But it's important that you do this in a systematic way. A sample space is a systemic, or I should say, right, which is it's in a system or a well-organized list of all possible outcomes. So if we wanted the sample space of rolling a single die, here they are. There's a 1, a 2, a 3, a 4, a 5, and a 6. And that's looking at all that could happen. And now if I say find the probability that the number you rolled is less than 5, I said less than 5, not less than or equal to 5, which would have a different answer. Less than 5, out of the 6 that are there on the bottom, 1, 2, 3, and 4, those 4 are going to be less than 5. 4 out of 6 reduces to 2/3. 2/3 of the time, you will roll that single die, and your number will show up as less than 5. That's the probability. But this organized one, I didn't have like, let's do it this way. Let's see. 2, 3, 6, 5, 4, 1. That's them, but that's kind of tough. Having them in order was really helpful when I said, let's keep it below 5, because as soon as I reached 5 and all the rest were above it, I was able to see that I could stop counting those in. I also recommend that when you're doing a probability, establish the denominator first. What's everything? Put that down, literally down, in the basement, in the denominator of your fraction. Then go look for specifics of what you're dealing with. And I can look at a problem where you don't get it perfectly right, where you've got a 6 in the denominator, and say, okay, they knew there were 6 total cases, and if it's supposed to be a 3 and you have a 4, I can't give you full credit, but I can see you have it as a fraction. I can see it's based on 6 possible outcomes, but you made a misassessment of what was going on, and you did learn something and demonstrate mastery of that. So an unreduced fraction is very helpful for that. And I want to go over a couple things that we've dealt with previously. And and or are going to work their way into the homework. I can say things about and or right now, and that could be, I'm saying I'm wearing glasses or sandals. Okay, we're doing or first. I'm wearing glasses or sandals. I didn't say glasses or sandals exclusively, but just at least one of them with or. I need to have at least one of them on. So if we're saying wearing glasses or sandals, if I have at least one of those, then we're going to say yes. So I have glasses, so that locks it up. You don't even have to worry about whether I'm wearing sandals. Okay, the glasses do it because of the or. Or needs at least one. If I need you to be, when we're on campus, I need you to be either on Route 1 or in Norwalk. Well, if you're sitting on campus at Norwalk Community College, you're fine, you're in Norwalk. If I need you to be on Route 1 or you just needed one, you didn't need to be both. But if I said I need you to be on Route 1 and in Norwalk, you'd have to be somewhere, you know, maybe Chipotle, maybe somewhere downtown, but somewhere that's both in Norwalk and on Route 1, because and needs both. So it's only true for and if you've got both. It's true for or if you have at least one. So now, let me say that I am wearing, let's see, I'm wearing a tie or a ring. And so we look and I'm not wearing a tie. I'm not hiding it, no sneaky, tricky stuff. I'm not, okay? It still might happen because I am wearing a ring. And when I did get that done, I had a ring, that was enough to say, hey, he's got at least one, he's got the ring, that's the one he had, but we're good for that. Now, say I'm wearing a tie and a ring, you can see that there's no tie. Once you've confirmed that, nothing that happens, I could have 50 rings, I could have 10 on, you know, each finger on this plus the thumb. Not going to get it done because the tie portion wasn't taken care of. So for and you need both, for or you need at least one. How about this? I'm wearing a hat or I'm wearing sneakers. Okay, I'm wearing a hat. Do you have to look at the sneakers? No. What if I'm like hanging out behind the door and I say I'm wearing a hat or I'm wearing sneakers and you see my feet, you see there are sneakers. Do you have to wait for both? No. But now I'm wearing a hat or I'm wearing sneakers, and I am. See that? I don't know. But what about having both? Is that okay for or? Or needs at least one. I like to say it's overkill to have both. That doesn't mean a problem. It just means that having both also has at least one. But or needs at least one and needs both. And those are things that will help you look at if I say, what's the probability of rolling 2 dice that the number is odd or greater than 2. Now in that case, if I wanted the odd numbers, I'll underline them. Greater than 2, I'll put the cap on them. Okay. 1's good for being odd. 2's no good. 3's good for either reason, odd or greater than 2. 4's good for being greater than 2. 5's good for either reason. And 6 is good for being greater than 2. So if I said or, it's either greater than 2 or odd, how many? Gotta have at least one blue mark, and that's 5 out of the 6 numbers. If I said greater than 2 and odd, what's the probability? Out of the 6 of them. How many have both a cap and a basement? That's the 3 as well as the 5. That's 2 out of 6. You want to make it 1/3 and show off, okay? But I don't reward showing off. I do punish showing off that hides some successful work, right? if you put that as 2 over 6 and somehow you reduce that to 1/2, I'm going to have to mark that wrong because 1/2 doesn't show me much of anything other than it's a fraction. But 2 out of 6 would be good. Reduction to 1/3 would also be okay. And needs both, such as the 3 and the 5, or needs at least 1, 1, 3, 4, 5, 6. And you make those fractions. That should give you enough information to possibly start the homework, and if further information is needed, click into the homework number 1 video, and you'll see specifics about the problems that we have on our homework. Good luck.